Welcome again to Wickerson Studios as I continue with looking into the Ghpython node for Grasshopper. And I decided at this point there isn't really any playing around with Rhino script syntax as RS if you're trying to get to the Rhino Common namespaces, and the focus being on Rhino geometry as RG. Sometimes Rhino, I think, input, and certainly Rhino collections. So what I'm going to do here is pretty basic, and it couldn't be more 101 with Rhino Common development. And there's no getting around it. There's no point flying through this book, mimicking and copying scripts that work in Rhino script syntax when I actually want to break down the functions that are being provided for you there, because basically when you do an add polyline, add curve, or add interp curve, or add line, or add point, that's all doing work for you. So to really start getting an understanding of this, there's two ways about it. First of all, I want to recommend this man as the initial stage of starting to understand it. It's your best $50 you'll ever spend. It runs through quite a bit of information theoretically of what's happening, and really the shift from Rhino syntax into Rhino Common. It teaches you quite a bit about Python, but then as it gets into the modules and what Iron Python really is to Python, you're going to realize you have to go even deeper and deeper if you wanted to move outside of Iron Python. So to really become a Rhino developer, Rhino Common developer, you'll realize that's all through the C language, and probably C# is in my near or soon or later future to have to learn. The other thing you really have to accustom your eyes to is the developer.rhino3d.com. And you could go into the API, and you could go into here, and you could start running down saying the namespace geometry is going to give me all of these alphabetical ordered objects. You can hit it that way. You can also try and type in what you think you want, especially if you're dealing with geometries. But the best example comes out of this fellow telling me to go, instead of there, go into the samples. And this is where you're really at the cutting edge, I think, with Rhino Common, similar to what's going on if you were to look into it. Adding objects, blocks, curves, drawing, layers, picking and selection, viewports and views, and other, because those are things that they just couldn't fit into these categories. I'm going to break these into groups if I can. We'll start with the adding objects, and we'll only go into the added objects right here. There's not thousands of them. But basically, find the ones in here that actually use not just C#, VB.NET, but take a look at Python, and you'll find this is put together by Steve Bear. So thank you, Steve Bear. I've been following your name for a while, but you literally can go into these functions he's created. So you could cut and paste the whole things into your scripts. Keep in mind of what's been imported. And but what I'm doing is a simpler version of that, because this is an introductory. This is the thing I need. I'm not wise enough to get in there and know where I want to go, know the difference between script context, system GUIDs, all this stuff. I literally just want to grab my Rhino that's tied to Rhino geometry and see what is necessary to grab a point, to grab a different point that's been hard-coded at 10, 10, 10, be able to build a box. Obviously, it's got to be stepped up a little bit to end up with a brep box. So what I'm grabbing is basically this script, and then I'll go back and jump in here again and say, okay, let's add cone. Let's find out in the Python example what language is being used, and there it is. It needs a plane, a height, radius, and then cone can be generated. I'll then go back in and I'll grab something like, and actually add line's a pretty tricky thing. I'll just show you here. Add line's a lot more complex than you think, because same with dimensions. You don't see a lot of Rhino geometry in here. You've actually gone in and had to use the input to get that started, input the other point, because you want to basically interface with people. And it's really tight and nice, but I don't want to end with that add line, which would seem the simplest thing. It gets pretty complex with the Nurbs curves. The Taurus itself is fairly interesting. going in and having to find the parts. And I don't fully understand why I would want to revolve surface afterwards. I'm pretty happy just to take this top portion and find out what is necessary, major, minor radius, and the plane, and that makes sense to build a torus. So you're literally scripting before functions. You're making the functions that Rhino script ends up using. So without getting too confusing, it's a very simple system I've set up. I've made these geometries, the points, which are hard to see here. There they are. There's one point. There's the second point. There's the line between them. There's a box. There's a circle that's being generated as we go in here. Maybe if I just made this a little larger. I've got a plane that's generated. I've got a geometry of a cone. I've got a geometry of a cylinder, a Nurbs curve, which is actually one of the most interesting things on here. I've got a sphere. I have a sphere here. There's a torus. There's a truncated cone. And then I actually have a truncated cone brep and the revolved surface. I'm not sure why I pulled that out. Oh, that's because I ran the script on. You'll see why. Revolved surface was one that was tied to here, but since the script is all in one, it ran this one later. So we'll get through it, and here's how it works. So without looking at anything particularly, maybe that's how we'll go about it. Let's take a look at the point. And what I did was said, I'm not going to be importing Rhino script syntax if I can help it. Sometimes Steve Bear's still doing that in the Rhino Common space, and you'll see that with certain objects that it just makes sense to do that. And I might use Rhino collections as RC. So be looking for RG and looking for RC. And like I said, it's not going to be a very exciting view to generate these geometries. And you'll say, boy, I could really make those faster just working in Rhino. Well, of course you can. But if you take the time to do this, you're going to get more and more proficient. And it is like your mind will hit another plateau. So the plateau of Grasshopper, the plateau of Python, the plateau of RhinoScript, the plateau of Rhino Common, the plateau of the namespaces. And it just takes a lot of work and a lot of practice, like learning any instrument. But we can see here a substitute for add point from RhinoScript. I just put in comments, I want to make this point this way, so I'll generate a point, which is what I plugged in here, and what the output is. And I really wanted to come off of 3 inputs, which are just basically, if I took a look at this whole unit, my slider, everything's parametric to that slider, except for my torus and my truncated cone. I decided not to use those first XYZ to make the points. I generated hard-coded points. And that will make sense in a minute for programmers or people that kind of can follow along what I'm doing. So the point here is pretty simple. Point, hard-coded in at XYZ at 222, and that's why you have a point at 222. I hard-coded a Rhino geometry dot system of point 3D at X plus 12, then Y and Z. So you've got this point and this point. Just moved it over in the X-axis. Very simple. Once those two are made, I can think of the next geometry I want to make, which is a line. And you make a line from Rhino geometry dot line, and you need a Rhino geometry point generated and a Rhino geometry point generated. Well, that's exactly what I did up here. So I simply wrote that script again with line ln equals Rhino geometry, because that's my shortcut, because that's how I imported it. And you need 2 line, and then you need 2 attributes, which will be 0.1 and 0.2. I just brought them in from the script above, and I'm left with the line between them. Simple enough. But you've got to learn this, and you've got to put it in your head. Otherwise, you're going to be looking for add line and looking for Rhino script functions. You don't want to do that. You want to be able to go in here, go back into all those wonderful scripts that are in the samples that flow through in C#, VBNet, and Python, all tied back to all the Rhino Common things you think you might be wanting to do. And like I said, we're going to go through a few of these added objects that really depend on Rhino geometry to start. I hope this makes sense, and I hope this is helpful for people, but there is no tutorial to watch that's going to tell you how to do this. You've got to get like the developers, get in here and on the level of some of these are left blank, and wouldn't it be interesting to draw a script and send it to Steve Bear? Oh, if I could only do that and wrap my head around it. The next is a brep box, and it's going to require a bounding box, and it's kind of nice to read these backwards, just like when I read a Grasshopper finished script from right to left, even though it's built and runs left to right. So it you would have a brep. You could just set your variable equal to box dot to brep and then leave it open. And what I'm doing with that is, I believe I put in the brep here. I did not put the box in here. You would see the bounding box if I did that. And I had to stagger the points. So I staggered the points by leaving the first one the same as 0.1, which is actually the exact same as up here. So I could just call that 0.1, but I'd have to change my script to that. So I guess I could, for simplicity's sake, change this back to 1 and take this one out. And all I really had to do was step off on a diagonal. If I just step straight in the XYZ, it's not going to work. So this may still work as a bounding box. Let's see, and it does. And I took out one step, and I basically have my first point as XYZ, my second point up plus 10 in XYZ, and then that's the bounding box contained within 0.1 to 0.4, because that's how you make a bounding box. And then you learn how to make the brep box to brep. You take an object and you want to make a boundary representation of it. So that's going to come back and be very interesting when we use it again and again. Try and keep in mind we have 0.1 defined, 0.2 defined, this line defined, this 0.4 defined, and let's see where we use it again. So great example here is the next one, a circle. All I did was go up to the corner of that box, which is right here, because that was 0.1 and that's 0.4. And then I made that the center. The radius is set to x, which means I can change that parametrically, but when doing so, obviously the center 0.4 is dependent on x, so my circle moves off in one direction. You should understand your code in the Python window, you should understand it in the Grasshopper window, and you should understand why things are happening in the Rhino window. This is a dry, boring, but it is easier. It's lower on the scale of 101 plateau of getting into Rhino Common, but I have to do this, and I have to start seeing these things while I sleep at night. So the circle is basically a Rhino geometry. I could have typed in the longer script here like I did for the bounding box with the points and everything within it, but you don't want to be scripting like this. You want to script much smaller like this. So basically, Rhino geometry is a circle which has two attributes, center and radius, which are defined by points that are farther up, and one of which is parametric. So I hope this makes sense. We're going to keep going. Nice simple one is Rhino is a plane, requires Rhino dot geometry, which we'll use as RG. It needs a plane, and it just needs 3 points. So I generated 0.1, 0.2, and 0.4, and that sets the plane off on a interesting, at least I believed it did. My plane, if I take a look here, what did I do wrong? Probably, did I take out one of my... did I take off one of my... Oh, I'm sure I just... No, there's a fun example. Yeah, basically it's a plane that's drawn using those 3 points of 0.1, 0.4, and 0.0, and then this plane comes from it. 0.1 is where it's going to be based out of, because that's... I have to wonder if I took 0.1 and 0.2, because the other ones are for orientation. So as I take this and move that to 0.1 and run it, I thought perhaps that would jump over. I'm not sure why. Oh, it's the same plane at that same origin. It's just going to actually have it. I'll have to put up something different if I want that plane to move somewhere else, because the points are only providing an orientation for it. As far as I know, if I'm wrong, I'll correct myself later when I watch the video and become a little more intelligent. Hopefully I do become more intelligent. The cone is interesting. It requires a plane, and the plane that's set, I decided to call the plane for the cone XY. And so I found out that Rhino geometry set at a plane has a dot. And if you're not wondering where I'm coming up with these, if I type dot here, it then gives me this chance of world XY. So I could easily change that to YZ, run the script, and my cone should definitely change in accordance to that. So you can still get in here and change everything by the Python script. And then with that, it still is parametric in size and scale because of my X and Y that have been brought in as my 3 simple inputs. All these inputs have been set to, I believe, single item type integer. And there it is. It says that while you hover over them. That's all you really have to do in these Python nodes besides open them up. You do an awful lot in the script. Cylinder, if we jump over to this geometry, and here it is on a bit of an angle. How come that is on an angle? And is it still parametric? Yes, because it's tied to my original points. And I may show you what later. I've got an idea to show you something. It needs a center point, and I decided to use 0.2, which is over here instead of over there. If you forget, there's 0.2. It then uses the height point at 0.4, which is going to jump over to this top part of the box, if you remember that. And the z-axis will be the height from here to here, so it has to follow in that direction as a vector. And my plane cylinder has to equal Rhino geometry equals plane, and you'll need a center point and an axis, and that's exactly what I plug in. The radius of my cylinder, I decided to have some fun with the math, and I could just quickly change that from x plus y to x times y, and I believe we're going to get a much taller. Oh, sorry. Well, that's interesting. Unless my radius runs, that's interesting. That because it's yes. Okay, sorry. I've got it. It was just adding them up to a certain number, and of course it would add up a lot higher. But you're not going to notice a change until you actually change. And 2 plus 2 is the same as 2 times 2. So you got to change this if you want to actually see that. Hang on a second, Max. I'm just finishing up here. The circle cylinder is then built by Rhino geometry. You have to construct a circle for it. And I should have read this backwards. The breadth of the cylinder is dependent upon the cylinder, and the cylinder is dependent upon the circle. And I've seen a lot of times while people script and write in Rhino syntax, script syntax, and in Rhino Common, including Jeremy Graham, they do kind of say, I need to get here, but what do I need to get there? So they go up a step, and slowly kind of deconstruct this whole cylinder into its cylinder circles, and then its cylinder radiuses, and its cylinder plane. It actually makes incredible sense, and it's so structural. I don't know how you couldn't follow it unless you were bored to death doing it and you didn't want to do it. I happen to have this crazy desire to do it. Now the next one is a Nurbs curve, and this is going to throw us. Like it's so easier to look in and grab points from some random box and get yourself add polyline, add curve, add interpolated curve, and all that. But the language for here is a totally different animal. And so I said Nurbs curve, which I probably should write out Nurbs curve and not confuse people. Nurbs curve. And then I should go down here to Nurbs curve and say, okay, let's type in Nurbs curve, making sure that everything is exactly the same. Otherwise, it will not run. Let's see if that runs. Yeah. The Nurbs curve is generated by Rhino geometry Nurbs curve, and I've seen some people shorten that also because they're using it all the time. And you literally hit create. It has a false Boolean, it has a degree, and it has the points that make it up. And of course, you have to construct those points, and I'd never thought to make a point 3D list of 5 points by writing them afterwards. So points are then added, add a point, add a point, add a point, add a point. So you can literally manipulate this by, if I take that 13 down to 1 and run it again, it's going to pull that Nurbs curve over here. This is such an incredible system that's not simple, but in not being simple, you gain such a level of control. I think I'm going to write some scripts that, even though this looks pretty boring, to gain control of this and build geometries from these curves is really essential for making beautiful forms. And I think there's something very zen about this, in the sense of laying ink to paper, letting the hand flow, letting the mind move. Conceptually, this is worth a whole hour tutorial on Nurbs curves alone, as far as I'm concerned. I've yet to find one online. We're already at an 18-minute mark. This is a long one. We're going to go into the circle cylinder, which, reading that one backwards, is fairly simple. You're going to need a sphere, which is going to require Rhino geometry.sphere. You'll need a center and a radius. So you basically go backwards on that. And I think at this point, the center doesn't have to be generated hard code like that. I could say center is simply point whatever, 0.4, since it was there. And in doing that and making the radius something like x, and running that, it's going to jump and go up here. But then once again, I've got something not hard-coded. And so when I start throwing all my objects in here, I can have this really crazy geometrical parametric model of everything within one node, which is pretty exciting. Because if you've been working clusters and thinking what you're actually doing there as a scripter in Grasshopper without being a Python scripter, I mean, that's kind of a big jump. And for those that actually want to be back-end developers and get right into the nitty-gritty of what generates and makes things and start doing plugins, you're going to take this language. Once again, I'm going to grab this over here again, and you're going to go into here as the samples. But as you're doing your samples, you're going to find, why am I even bothering with Python when I should be learning C#? And like I said, I think if you know Python, it's going to be a lot easier to jump into the details of what's going on here if you know Java or something else. Anyhow, I'm very excited with the direction of my life. I still am basing this on beauty, on aesthetics, and on sculpture and design. I just have to be successful at it for others to appreciate what I'm trying to do. So we're after the Nurbs Curve. What's the next one? The sphere. The next geometry is a torus, and the torus is a strange thing. I don't really use it, probably because of Andrew Price. But let's jump in there and see what it requires. The torus has this revolved surface torus, and that's why that other one was coming up, because I used that revolved surface again, create revolved surface from surface down here on the truncated cone. So it overrode and put that in here. Revolved surface. I don't know if I need that, and I'm getting ahead of myself, but just, yes, I definitely need that. So let's just go back out of here and run it again. Just getting ahead of myself because I did delete it out of here. It comes after the torus. The torus is made by Rhino Geometry Torus. You need a plane, a major and minor radius. That plane can be changed from X, Y to, well, whatever you want, Y, Z. I mean, if you really want to orient your torus differently. You gain a lot of control. And that's any plane, of course. So when you gain control of the plane, you'll remember that plane was the plane I was playing with up here under plane. Sorry to jump around, but I did make a plane earlier, and I've got a very small area script to look at here. Probably should make it a little bigger. I had a plane in here at some point. There it is. So that's the plane that I'm importing, dependent on points. So that torus can work fairly easily by just grabbing that, and then I just needed 2 new attributes. And those radius, they once again could be set to Y. I mean, you can make them parametric Y. They are set as floats, but I think they'll be fine as integers. So if I set it X and Y and I do that, what happened? Sorry. Maybe because they are a decimal. Well, that doesn't make sense to me. If the major radius is just a number, I should be able to hard code whatever I want. But let me just try this again. Let me take that up at 15 and see how it runs. Yeah, it works. You'd think my parameter of X and Y and Z would work fine here. Let me try that again. No, I've got a problem with that and the reference. Oh, that's because we're actually dealing with an instance of the object. Okay, object reference. Oh, okay. I'll worry about that later when I can wrap my head around it. But I'm thinking myself through some of my mistakes. I'll just skip over it. Truncated cone is one that was here. The truncated cone produces a wonderful long script. I'll try and bring it all in here, and I'll just take this up so we can see it. Truncated cone's an interesting monster. It's the last one in the section that really was using geometry, and I think it's a good example of everything coming together at once. I've made a bottom point, and at 0, 0, 0, so I could change that to whatever 2, 0, 0. Run it again. You'll see my truncated cone is kind of moving and doing some awkward things as I move it. If I set it up in the Y direction 4, you can start to pull it over in that angle. And the bottom radius is 2, but I could change that radius to this. I shouldn't have a problem with X, so I could actually make that radius. Yeah, I was hoping to do that with the other one. But you can see how you can start to make it parametric. The radius here could be Y, which is going to be kind of boring because they're the same scripts. I need to run it if I want to do that. There we go. So now you've just made a cylinder because you've kept them the same. So what I would normally do is grab here and here. It's just going to take a second because when you double that, you're changing all the scripts that are in here. So it takes a second to run. You have to think you're running all of these things out of the same script. And now when I take a look at it there, I've got an ability to go into controlling my Y, controlling my X on my truncated cone. It needs a revolved surface, and this makes sense to me, the revolved surface, which I actually put in here, and you'll see where it is. It's basically that revolved surface as opposed to the truncated cone, which closes it off, and that's exactly what it does. It does a boundary representation. It's like a capping. It's making a boundary representation closed of that form. But you definitely have to make the revolved surface first. And I guess that's what was happening back here in my torus, was there was this type of revolved surface that I've yet to figure out exactly what's going on. Max, can you turn that down a bit? Thank you. And he's managed to get his own movie on. I think we're just about done at 25 minutes. Yeah, only one kid at home allows me to do these longer videos. It should be self-explanatory, but if you get lost in it, you're going to want to go in. At this point, when I start seeing attributes like revolved surface and 2 booleans, I'm like, at what point was I doing enough in the example that was given to me by Steve Baer? And at what point do I want to go in and see exactly what's optional or not? So if I went in back into here, and this might be, I might fail terribly at this because I don't do this so often. We'll go back into here. We'll go back into our Rhino Common. We might go into our, oh my gosh. Actually, I'll go back out. I'll go to my API and just go into my Rhino Common and be like, I want a cone. Oh, this is going to be wild. What was it? Yeah, it was a truncated cone, maybe? Oh, now it's like, what do you want? Yeah, I think that was my final form. Now I'm just thinking. Yeah, truncated cone. It's got to get a create from revolved surface. No, that's really where I have to go, is this brep. And then you're getting into all this other information that if I'm looking here and I'm trying to find things from what I know in this search, I just get lost and I still get a little frustrated with it. What I do follow is Jeremy Graham's suggestion to go into the samples and have as much look as you can in here. And because there's a Rhino Common area, we're then going to go into these block systems. I'm going to go to add nested block and see if there's anything I can pull out of here. And once again, there's one that has not been put into Python by Steve Baer. And you may run into a lot of those if you're getting into some complex things. Block intersection point. There it is. And if I look at it, I see Rhino, which is not specific to any namespace. What could I pull from there and say, what is going on? And this is one that I'm going to focus on pretty soon if I can't find a lot more geometries, which I know I can. But then I'm going to go into the input, and I'm going to actually also go into the namespace here. I got to start over. API. I'm going to also go into not just the Rhino geometries. I'm going to go into the Rhino collections and the Rhino inputs. And I think outside of having them in this alphabetical kind of order of going through the Git class and all these things, it's going to make sense to see Steve Baer's Python scripts alongside C# if you knew it. I hope that makes sense. It's a long, complex video for me, but it does show that I'm hitting another tiered level of what I'm willing to do. We will wrap this one up probably as a video. I will just test it, okay, and close it. It's this interesting little example with all these wonderful things. And whereas I used to be dependent on things like bifocals to know what I'm doing, it really is the Python node. So if I was to color code this very simply to what I'm doing, this becomes a group. This becomes a nice blob cluster. We're going to change that color to, oh, takes me a second. This is how I'm kind of teaching towards this, a lovely green, and what an ugly blob it is. The Python node itself is grouped. It will be a colored blob, and if that ever doesn't work on you, you have to ungroup it, and it doesn't fully go away, and then you click on it again. It's like it groups it twice. I don't know why. I've just had trouble with that. Maybe it's Rhino 5. It's a little bug that bothers me. The red is to stop and look at the Python, and over here we've got a few samples of grouping, and this is so primary, but I think it's nice to do something simple after you've kind of stressed your mind out, and grab the yellow and put that in a blob. So basically we have the red, yellow, green look of these scripts, and if I double clicked here, you'd see I've got a pretty cool Python script that pairs against it. And there is our monstrosity. Not the most exciting thing in the world to make. Once again, people have always said, why you learn Grasshopper? I'm faster at Rhino with it. But at some point, you not only get faster, you get more intelligent, you get deeper with it all. And I could still play with a lot of these things. I think it's fun to run that all through one node and have all these different geometries. 30 minutes straight. I hope you enjoy this tutorial. It's a little dry. Don't know how many people are going to watch it. But I will continue, and the more I learn Rhino geometry at RG, I'll have no problem switching back over into some of the Rhino script functions. But you're asking a lot of stuff to be coded in Rhino Common that is normally being handed to you in function form in Rhino script syntax. So this book's going to get a lot harder, a lot quicker than I thought, and I'll probably not follow the examples in it because they're highly complex with Rhino script syntax, and I'll have to dull things down to the basics in Rhino Common. Thanks for watching. I'm Michael Wickerson at Wickerson Studios, the last Canadian man in America.